All right, guys. I'm sorry I couldn't be there today. My back is giving me issues, but I hope to be there Wednesday and Thursday. Um, okay, so let's get into our first lesson in college algebra. So hopefully this is mostly review this bit about linear equations. I'm sure y'all are familiar with y equals mx plus b being the slope-intercept form of a linear equation. Here's also another standard form of a linear equation. Not standard form, but just a form referenced in the textbook. I'm sure we all know what a solution is. It's a value that makes an equation true. A lot of times we represent solutions in a solution set, even if there's just one solution. And typically solution sets are inside curly braces as such. So if I wanted to write the solutions for x squared equals 9, well, if we take the square root of both sides, we know it's plus or minus root 9. So the solution set would be negative 3 and 3 inside curly braces. If a solution doesn't have, if an equation doesn't have a solution, we typically say it doesn't have a solution set, which is the same as the symbol, meaning null set. All right, let's do some examples of solving linear equations. All right, if we look at number 1, we got x over 6 equals 4. So the opposite of division is multiplication. So we must do that to both sides. To solve for x, 6 is canceled on the left. So x equals 24. All right, number 2, anytime we see parentheses, we want to remember we want to distribute if we can. On that first set of parentheses, we can imagine there's a 1 in front of it. So, 1 times both those would just be x plus 3. So really no need to do that bit right there. You can just drop the parentheses when you see nothing in front of the factor. Distribute the negative 7. All right. And then next is to combine like terms. Plus 3 minus 14 is minus 11. Let's add 11 to both sides. Let's see. And then we can divide by 6, negative 6. So we got x equals 39 over negative 6. That is, both of those are divisible by 3. So we can make that 13 over negative 2. And remember that negative, it doesn't matter where you place it. It could be in the numerator out in front of the fraction. All right, the next one, anytime we see fractions, we try to get rid of them. So I'm going to multiply everything by 3, just to get rid of that 3 I see right here. So the 3 is going to cancel on the first fraction. 3 times 7x is 21x over 5. And then 3 times minus 2 is minus 6. Okay, and then we could get rid of the 5 as well by multiplying everything by 5. So we get 20x. 5s are going to cancel there. And then minus 30, okay? And then minus the 21x to both sides. So negative x equals negative 30. Multiply both sides by negative 1, so x equals 30. All right, let's multiply everything by, so I'm looking at number 4, and I'm thinking we have 3 fractions, so we'll start getting rid of them by multiplying by the denominators. All right, so if we multiply everything by 18, so we'll distribute it and multiply it to the first fraction, so it'll cancel out the 18s, just leaving the numerator. Here, 18 over 9 is 2, so 2 times 2 is 4. And then 18 over 5 doesn't simplify, so we'll just distribute the 18 to the top. 18 times 8, what is that? 80 plus 64, 144. So minus 144 all over 5. And then we can multiply everything by 5 to get rid of the last denominator, right? So we get 5x plus 5 equals 20, and then that denominator will cancel. All right, and then we will get all the x's to one side, and we'll get all the constants to the other. So we'll subtract 5x from both sides. Well, we can combine the 20 and minus 144 real quick also. Make that negative 124. Okay. Add 124 to the other side. And divide by 13. And I don't think that simplifies, so we'll leave it like that. All right, so number 5, we're going to take the same strategy to solve this linear equation. We see two fractions, and we're going to tackle it by multiplying by one of the denominators first. All right, so we multiply by 4. So the 4's cancel in this first fraction, leaving 1x. We can just write x. Nothing cancels here when we multiply, so just multiply 4 to 3 in the numerator. So 12 over 5, and then equals 8. All right, this time we could add 12 over 5 to both sides, but I'm going to keep taking my strategy of multiplying by the denominators. So we see that 5 in the bottom of the fraction, so we'll multiply everything by 5. So we get 5x minus 12, because the 5's cancel, and then equals 40. All right, we'll add 12 to both sides, and we'll get 5x equals 52. And then we'll divide by 5, and we'll get 52 over 5, or decimals are okay as well. 10.4 is fine. Okay, on this one, it's an application problem of a linear equation. So for a recent year, the cost C in dollars for tuition and fees for X credit hours at a public college was given by that equation. And part A says, how much does it cost to take 9 hours? Okay, so that we need to identify is our X or a C. And so it's credit hours, so we know X equals 9. So we're going to plug that into our cost equation. And we can just plug in the 9 for X. And you'll find in college algebra, we can use calculators for everything. You still need to show your work on everything, but you can use a calculator at this point. So that's what we'll do. Okay, so let's 167.95 times 9 plus 94. Okay. Okay, next part. If Josie spent that much money for classes, how many credit hours did she take? So this is working backwards. So we plug that value in for C into our equation, and we're going to solve for X. So we'll start by subtracting 94 from both sides. Okay. And then lastly, we'll divide both sides by the 167.95. And we get 14 credit hours. Okay, and then down below is asking us to solve for a specific variable when there's multiple variables in the equation. So for instance, number 7 is a very common equation, distance equals rate times time. We want to solve for t, so we want to divide both sides by what's attached to it, which is r. So t equals distance over r rate. 8, also another common equation. Area equals base times height. Solve for base, divide by what's attached to it. So the base equals area over height. Okay, and then number 9, we want to solve for y. So we want to isolate it. So we'll first start by subtracting 7x from both sides. So we get 2y equals negative 7x plus 8. And then we'll divide everything by the coefficient that's attached to y. So we'll divide everything by 2. So we get y equals negative 7 over 2x plus 4. Right, and we would do the same thing for number 10, so we'll skip that one. All right, so we just got done covering linear equations, so we're going to talk about rational equations now. So a rational equation is something where it typically has a fraction where the variable's in the denominator of at least one of the fractions. And so the first thing we do when we solve rational equations is we figure out what the equation cannot equal. So that would be any values of x that make the denominator 0. So if we look at number 11, for instance, we see x cannot equal 0, because that would make this fraction and this fraction both 0 in the denominator. So the next step is to start solving. And so we're going to take the same strategy I was doing earlier with linear equations. So I'm going to multiply everything by x. We could do 4x as well. Let's actually do 4x, because that'll get rid of all the denominators at one time. So okay, so if we multiply 4x to the first fraction, the x's are going to cancel, just leaving 4 times 3. The 4x times the 9 over 4x, the 4x's are going to cancel, just leaving 9. And then, and then 4x times 3 is 12x. All right, so I get 12 equals 9 plus 12x. Subtract the 9 over, and then divide by 12. So 3 over 12 equals 1/4. Okay, and so you want to make sure this is not matching any values that we established in the beginning. The x cannot equal. So since 1/4 is not 0, we're good. 1/4 is the solution. All right, let's look at 12. So we're looking at the denominators first, and we see the x plus 3. So x plus 3 cannot equal 0, right? So if you subtract 3 from both sides, we establish x cannot equal negative 3. So that's our restriction. Okay, so we're going to start solving. So we'll multiply everything by x plus 3. Okay, so we multiply the first fraction. Everything cancels. And the x plus 3 and the x plus 3 cancel, leaving 1. X plus 3 times 4 is 4 times x plus 3. X plus 3 times that last fraction will cancel out the denominator, just leaving 21. All right, so we can just solve this from there. Distribute the 4. Okay, 4x, combine the 1 and the 12 to get 13. Subtract the 13 from both sides to get 8. So x equals 8 divided by 4 is 2. Again, check against your restrictions. It's not the same thing, so we're good. All right, 13. We're looking at the denominator first. 5x minus 20 cannot equal 0, right? All right, so we're going to solve this. So add 20. So x cannot equal 4. All right, so we're going to solve this equation by multiplying everything by 5x minus 20. All right, so that'll cancel everything, right? Just leaving the numerators. All right, so let's see. Okay, we'll add 4x to both sides. Divide by 36, and we get 4. But this what we found in the beginning, x cannot equal 4. So there's no solution to this equation. And that would be fine if you wrote this on a test for me. On the homework assignment, you might have to select this as the null set. All right, 14. We have two different denominators, so we want to set both of those not equal to 0. So we see, okay, x cannot equal negative 1/2 if we solve that. And then 3x minus 4 cannot equal 0 as well. And if we solve that, x could not equal 4/3. Okay, so we're going to multiply everything by 2x plus 1 and 3x minus 4 at the same time. Alternatively, since this is just one fraction equals another fraction, you could just cross multiply here to make it easy. And you know what? We'll do that. So let's do that. Okay, so we get 5 times 3x minus 4 equals negative 2 times 2x plus 1. Distribute on both sides. Add 4x to both sides. Let's see, add 20 to both sides. And divide by 19. Okay, so I'm showing a lot of steps, but if this was a test, if you just showed maybe like this line, and maybe just like jumping to the bottom from there, just a few of those steps would be sufficient. Okay, on this problem we see x, because of the x plus 6 factor on the left, x cannot equal negative 6. The x minus 6 factor in the middle means x equals 6. It's not possible either. And then hopefully we know x squared minus 36 is the difference of squares. So that actually factors into x plus 6, x minus 6. And I'm actually going to just replace the denominator with its factored form. So it'll be easier when I multiply by what I need to. So the lowest common denominator is x plus 6, x minus 6. So let's see. So we'll multiply everything by x minus 6, x plus 6. So when we multiply the first fraction, the x plus 6's will cancel, right? Just leaving 3 times x minus 6. Okay? And then, let's see. So next we'll multiply those same two factors here to the second fraction. So it'll be minus, let's see what cancels first. The x minus 6 cancels, leaving minus 2, right, for the numerator. And then times the x plus 6 factor left. Right? Okay. And then lastly, when we multiply those two factors to the last fraction, those factors will completely cancel out everything, leaving just 4x on the right side. All right, and then we can just solve it like normal. So we'll distribute the 3 here, distribute the minus 2, combine like terms. We'll subtract the x over, divide by 3, so x equals negative 10. Do a quick check against the restrictions, and we're good. All right, 16. I'm going to go ahead and just factor that quadratic denominator real quick. So factors of negative 18 that add up to 3 are x plus 6, x minus 3. And you'll notice that those factors are the same as the two denominators that are being added or subtracted to form that quadratic. And that's typically how you'll see these problems. They'll have common factors in the other fractions, so it makes it really easy to factor. All right, so what can x not equal? X cannot equal 3, right? Based off that factor, and x cannot equal -6 off that factor. All right, so what are we going to do next? We're going to multiply it by the lowest common denominator, which is essentially just all the factors we see that they have in common. So x minus 3, x plus 6 is what we need to multiply everything by. Okay, so we'll multiply those two factors to the first fraction. All right, what cancels? The x minus 3. So it'll leave x plus 6 times 1, right? Which is this x plus 6. All right, and then we'll distribute those same two factors to the middle fraction. So it'll be minus, the x plus 6 cancels, minus 5 times x minus 3. All right, and then lastly, those two factors being multiplied to that last fraction will just completely cancel out the denominator, just leaving 9. All right, so we'll solve it from there. So we'll just drop the parentheses here, distribute the minus 5, combine like terms. Uh, 9 minus 12, and then divide by -4, so x equals 3. We see that's a restriction. We can't equal 3. That's an extraneous solution. So we say there's no solution, or use the null set indicator if this was a homework problem. All right, on this last problem, we're going to utilize the calculator. So one way you can solve an equation like this is you can set, but you can put both expressions into y equals. So notice I have that expression that I circled in y1, this expression in y2. And so after you do this, you can go to the table. So you can hit second graph, and you just scroll through the table until you see the same y value appear. So there we go. So at x equals 3, that is the solution because they have the same y value of 5.